Promises. So let's try number 20 and 2.3. So what we have to start with is y prime is 3x times the quantity y minus 1 to the 1/3 power. And they give us an initial value, which is y of 3 is -7. Okay? So, cool. Good. Thoughts? What do I try?
First thing, separation of variables.
Okay, let's try separation of variables. That seems like a great idea.
Then
Why is separation of variables a better idea than other things?
Because at this point,
not linear.
Yeah, okay, because we don't know that many things, right? So, is it linear?
No.
No. Is it Bernoulli?
I don't know.
Probably
Like, in
Not.
2.3,
Bernoulli doesn't have funny not integer powers in it. Well, maybe it kind of does. I could maybe make Bernoulli work for me, but only if I can get the y minus 1 out of that thing. That sounds like a substitution I'm not that psyched on making. We could try substitution maybe. Is this separable?
Yes.
Yeah? Cool, let's do separable, because that's not that bad. Okay, so if we separate variables, what's our first step here?
Divide both sides by y minus 1 to the 1/3.
Okay, so multiply both sides by y minus 1 to the minus 1/3.
Yep.
So you get y minus 1 to the minus 1/3. Oh, and you may as well multiply by dx too,
Yeah.
huh? So you get y minus 1 to the negative 1/3 dy is 3x dx. Okay, yeah, the right side's chill.
I think both of them are pretty nice.
Hopefully the left side's not too bad. I think we got this. So you slap yourself a squiggle on there, right? And then you got over here, you got 3x squared over 2 to my recollection of Calc 2. Calc 1 maybe? Plus constant, I guess.
Yep.
Okay, what do you do on the other side?
power rule thing.
Well,
Add 1 to the exponent.
no. Yeah, it's pretty much that.
No, not parts.
Oh,
Just straight u sub. So let u be y minus 1, then du is dy, right? Okay, you got your du right there. This jazz is a u. Okay, so now I got the integral of u to the minus 1/3 du. So I do the power rule thing to that. So I go to u to the 1 higher power is what? U to the 2/3. And then I need to divide by 2/3. So we'll multiply by 3 over 2, I guess. That seems legit. And what do I got on the other side? I got 3 over 2 x squared plus constant. Hey, things are looking up.
Substitute y back into for
Yeah.
one.
Actually, first, get rid of the 3 over 2.
Yeah. You can do that too.
Multiply the whole thing through by 2/3. Why didn't I change the c?
Because it's still
This is a constant, who cares? So I think I have y minus 1 to the 2/3 power is x squared.
Yeah. So that was the easy part.
Okay, good. At least we're warmed up now. All right, now. Oh, good call. Thank you, Tony. Plus C. Okay, now my next conundrum is that I need to do what?
Isolate the y.
You're right there.
Yeah, I should try to isolate y, right? So that
3/2.
reads like take all this crap to the 3/2 power. Right? So I got y minus 1 is x squared plus a constant all to the 3/2 power. So that reads like y is x squared plus a constant to the 3/2 power plus 1.
Yeah.
Now, do we need a plus or minus? Because we're
Yeah.
cubing it and then square rooting
Yeah.
it.
I think we need a plus or minus.
That's a really reasonable complaint, right? I just did the 3/2 power to both sides, which is fundamentally cubing it and then square rooting the result, right? Yeah, so really I should probably introduce a plus or minus over here. And really I should have had one there, right? You guys with that?
Yes.
Okay, now what's the question that I should be warmed up to answer?
Yeah, so that, and that was also an IVP, by the way, so,
Oh, cool, good.
Yeah.
What's my IVP? Oh, y of 3 is -7.
Yeah.
So, we should plug in. So y of 3, right, is plus or minus this, plus or minus 3 squared plus a c to the 3/2 power plus 1,
Yeah.
right?
Equals -7?
Which should in theory be -7.
Yeah.
Okay, so I'm now trying to solve for a c, right?
Yeah.
Okay, so I think I got plus or minus, that's gonna be weird.
Can we separate it?
And
Can we square it away if we get rid of that one?
Hang on, let's try this. So I got 9 plus c in there to the 3/2 power is -8.
Yeah. We need, wouldn't it be,
You guys with me on that?
could you make it a plus or -8 on the other side and just get rid of plus or minus on the, because it would.
That's a super idea.
You divide it, it'd be minus plus, and then it switches.
You guys with that?
Could you flip the 3/2 to the other side like you did last time and make it 8 to the 2/3?
That's a really good idea. And also, I could probably think, okay, if I'm getting this 9 plus c thing and I'm square rooting it, right? This part's going to be positive, right? So really only the negative one's going to matter, so really I may as well go with positive 8. Okay, down with that? And then we could flip the power through, right? So we'll do stuff to the 2/3 power. And at this point, I really want to highlight a moral lesson. On the other side there, I'm going to get 8 to the 2/3 power, right? Which is
4.
At 8.
4. And then you need to subtract 9. So you'll get c is -5, right? You guys with that? Another maybe better thought would have been over here, like at this stage, before you solve, plug in 3 for x and -7 for y. Right? Because, like, I'm going through all this arithmetic to unsolve the shit that I just solved for, right? You see that? Like, everything I'm doing here is backwards from something I just did over here.
Always looking ahead.
So instead of hunting this thing down, if you've got an implicit solution and an initial value, oftentimes that's the spot you want to do that plugging. Because right here, right, I got -8 to the 2/3 is 3 squared plus a constant.
And it's the same thing, square is positive, you could just erase the negative.
Yeah, and then because I'm squaring, right, so I got 4 is 9 plus c. That's the same thing I got over there, because of course it is. Because this whole business here, like this, is one big circle drawn on the board in math.
At least you know you didn't make any mistakes doing
But
that.
yeah, I do know that I did screw up solving.
But, okay,
So,
if we plug in 7 there, though, we get 6 to the 2/3.
-7.
Or
Plug in -7 for y.
-7?
So I got -7 minus 1 is -8.
Oh, -7, cool.
Okay, so I found out c is -5.
-7.
Okay, so someplace here I should be writing the solution that I got down, so far at least. So far what I know is that the y that satisfies this thing is y of x is, x squared minus 5 to the 3 halves plus 1. And then I'm kind of worried about the plus or minus, right? You guys see that? And my guess is that the thing they're asking for is when does this solution work, right?
Well, so for the solution, I just picked the minus, and I mean, that sort of seemed to work, but the thing that really tripped me up was they want us to find the largest interval of validity for that solution. And for part B, they want us to find infinitely many solutions of that thing, all defined on negative infinity to positive infinity. So those, you know, the intervals of validity thing, and then part B is what tripped me up.
Okay, so I think if I pick either the plus or minus branch here, right, I'll get some solution, right? You guys see that? So say I pick the plus branch just for kicks. So where is that solution valid?
When it's
Anywhere
minus
on-
5 is positive.
So X is, what, less than
If
root
you
5?
just pick the positive branch, then that's not going to be valid for that IDP.
Thank you.
It has to be negative.
Cool. So we pick the negative branch for the reason we talked about over there.
Yeah.
Right? So this is solving my IVP. And when is this solution valid? Well, it's going to be valid whenever this thing's not broken, right? Like that's the best it could possibly be.
So when x squared minus 5 is not.
So when is x squared minus 5 positive?
Yeah.
Seems like when x is bigger than root 5. Well, that's really
Would
not
that be
quite
like
accurate
the
either,
absolute
right?
value of x?
Yeah.
Because really I'm looking for this, right?
Yeah.
I'm looking for when is x squared shifted down 5 units positive.
Yeah. So it should be absolute
Okay,
value.
so here's a break even, that's at the square root of 5. Here's another break even, that's at minus the square root of 5, right? Okay, now which IVP did I, or where was the initial value that I calculated this thing at? Like where did I calibrate this sucker?
3.
It was at 3, which is
Bigger than root 5.
bigger than root 5.
That's
So this thing is valid only on that side. And the reason it's only valid on that side is that's where I calibrated it to solve the IVP. You guys see that? I don't know what the heck it's doing on the other side, which is what their point is as to what are other possible solutions.
Yeah.
So other possible solutions would look like y of x is this, for x is bigger than 5, and presumably the positive branch is the thing that's happening on the other side there.
But that wouldn't cover negative 5, root 5, 5, root 5. Right?
Yeah, this doesn't cover the stuff in the middle. That stuff's going to be fundamentally broken here.
Yeah.
Hang on.
And should we just have it a greater than root of 5 because we want to avoid
Oh yeah, we should probably avoid
minus
taking
1 equals-
derivatives that are one-sided. That's reasonable.
And also, we want to avoid y minus 1 equals 0 because we're dividing by that at some point.
Yes. Cool. Good call. Right, we divided by y minus 1 at some point. We would want to avoid that value. We could maybe make it work if we like fiddled with limits long enough, but yeah, let's stay away from that for now.
Does that mean that that entire orthogonal volume of y equals or y minus 1 is not valid for the solution set?
Yeah. Yeah, y minus 1 shouldn't be valid in the solution set because of the method I used to solve.
Just punching holes at that elevation.
Yeah, really it's saying at that spot y prime is 0, right? And presumably, what's breaking there? That's a good question. That's not totally in evidence.
Yeah, because
My feeling is that that's probably true. Those are probably spots that are problematic. But yeah, that's not totally in evidence. What was your guys' question?
Well, two things, I was a bit confused on. I didn't understand, you had a negative x squared minus 5 and the graph is pointing up. What makes that go up if it has a negative?
Oh, I'm just looking at x squared minus 5 by itself.
Okay.
Without the rest of that garbage. I just want to know when is the stuff in this square root negative.
Okay, and then another thing, you have the intersections there at square root of 5. That was just with the inner parentheses taken in mind?
Yeah, that's just with where is x squared minus 5 equal to 0.
Okay.
Yeah.
Because our final thing isn't even parabola, is it?
Because, I mean, just saying like that plus 1 on.
Yeah, the whole thing's not a parabola. Like, I don't even know what the whole thing looks like. Because it's a parabola raised to a 3/2 power. Morally speaking, it probably looks like some kind of cubic.
Yeah, it's,
But only where it's defined. So it should be noted that what I have here is not infinitely many solutions. You guys see that? Like, I lied to you a little bit. I said, okay, so the black stuff is definitely the solution we have for the interval on which we calibrated it. And the biggest interval we could ever hope for is x is bigger than the square root of 5. Right? Now, where
What
is
this funny thing?
where are the infinitely many solutions coming from?
Well, what I was thinking is the infinitely many solutions come from you slapping random shit to the ends of it.
Yeah, kind of. So where was the thing you were allowed to pick? Yeah, in the initial condition, right? What did you get to pick? So I got to pick a plus or minus branch. And also, what else did I get to pick? What else was I forced to pick? Yeah, I got to pick that C value, right? So right now, this is one solution on the right-hand side, right? We're sure that solves the IVP. And then some other stuff, this blue stuff is just like, I don't know what's going on the other side. Maybe I'll just assume it's basically the same thing. But it doesn't have to be the same thing. Because this 5 came from knowing that y of 3 is negative 7. You guys see that? This really should just be a plus c in there. And there's your infinitely many solutions, right? You have kind of a solution set parameterized by this constant c. Did I answer your question? Or?
Yeah, I just wanted to show you what the answer in the back of the book was. I was wondering for this part A, where the heck did they even get this 1 from? And so we got this part. And then it's saying that for x is between 0 and square root of 5, then y equals 1. And I'm like, where the heck did they get that?
Okay, so they also got the solution in the back of the book has one further thing that I should have noted. And this was pure oversight on my part. If you had y equals 1, you would have a problem, right?
Well, isn't that what you get then? When you're
So my question is, what is the problem you have when y is 1?
That just lets you know that x is equal to root 5 and not greater than root 5.
Theoretically, when
Oh,
y is 1, like the elevation.
Hold on, it just clicked, I think.
Did it? Okay, so I said when y is 1, we have a problem, right?
So-
Because I divided by y is 1. What I neglected to do was check
Right.
what?
Okay, so I think if you said y equals 1, then y prime is going to equal to 0.
Right? Y prime is 0 if y is 1 by both rules of differentiating and by substituting y is 1 in there.
Yeah.
You guys see that? So y is 1 actually also solves this differential equation. You guys see that?
Why do we say it solves instead of breaks the dividing by 0 thing?
Oh, because I was being an idiot. That was purely me. That was saying, oh, well, if you can't divide by it, probably it'll just break things. Well, generically that's true. Except for in the case where it also solves the differential
Yeah.
equation.
Oh, so it could have given us like an infinite derivative or something.
It could just have been meaningless, right? It could have just been like, oh, well, when y is 1, clearly this differential equation isn't solved, And so that's just values that are broken.
What does that mean when you plug that into your implicit form? And then you get.
When I plug this into
The
there,
bottom one,
oh, it's not valid.
it doesn't even work.
And the reason it's not valid is
Okay.
this solution was obtained by separating the variables and integrating, right?
Oh, but that thing had to be excluded too.
But you can't have y equals 1 to do that.
I see.
You guys see that? So y is 1 would certainly work to solve this differential equation. Right? So a possibility that you could do is you could say, okay, well, it's this when x is bigger than root 5, and it's maybe something else when x is smaller than root 5. And in between, you could just say it's 1. So you can add yet another thing here. And I think the best we could do is, oops, 0 is smaller than x is smaller than root 5. So the best we can do in terms of picking a function that doesn't have annoying branching in business is we could pick the black 2 and discard the blue.
When x is, when it's 1, why is it not minus root 5 less than x less?
Good question. That would also be fair. Let's see. So why can't you, where is that?
Like how we have, for the top equations, like x is greater than the root 5, and then the bottom equation's x less than minus root 5, but then the third one is 0 less than x less than root 5?
Shouldn't it be, yeah.
Yeah, shouldn't it be negative root 5? That was just intuition on my part. That's what the back of the book says too, right? So someplace there's a good reason for that. Where is it?
Because it doesn't exist and you're adding one to something that doesn't exist.
Let's see.
Plugging something between
Okay, so we solve.
Oh, they actually said negative alpha, where alpha is greater than or equal to 0. So, okay, so yeah, 0.
I don't know. That's a good question. Let me think about it a little bit. I don't have a good answer for that, obviously. Okay, so this is actually cool. I think we can fiddle with number 20 a little bit more. So, fundamentally, I think I need to decide whether or not there's an equal sign someplace here. So, let me just ask, is this function that I have, is it possible for me to extend that, making an equal sign on one side or the other here, and have this function still be differentiable? Okay, see that?
You have to figure out.
So I'd have to figure out the derivatives for each piece, right?
Yeah.
Okay, well, the derivative of the bottom is really easy. Right? So I'm kind of thinking like, hey, I'm just going to take this part, and I'm going to take the derivative with respect to x operator to it and see what I get. If I take the derivative with respect to x at the top, what do you get?
Negative 3x quantity.
So I think I got drop power x squared minus 5 times 2x,
When the parentheses be to 1/2.
Yeah.
and the parentheses should be to a 1/2 power. Okay, cool. And then if I plug x is the square root of 5 in there, right? Really, I'm kind of thinking to myself, hey, let's take a limit of this stuff as x tends to the square root of 5 from the positive side. But that function's continuous, well, at least from the left. What do you get?
Use with 0.
You get -0.
Why exactly did we get a different derivative when the derivative of y we started with?
Then the derivative of y we started. Well, there's a y in that thing.
Oh,
Right, so you'd have to plug all this crap in for y and simplify.
Oh, so since the point of contention has 2 zeros, we're going to put the equals on the...
Yeah, so what I'm going to say here is, okay, so the function values agree. If you plug in square root of 5 to the top part, you get 1, right? So I could make this function continuous by filling in one of these guys, right? Either one, actually. Like one of those would make this function continuous. And furthermore, because the derivatives also agree there, I could fill in one of these and still have a function that's differentiable. That's crazy,
Oh.
right?
So it's like identically one and then it perfectly smoothly
Yeah,
transitions.
exactly. So this smoothly transitions from being the constant function 1 into being this funky weirdness, right? And then there's some wondering about, okay, so this is a solution that works from 0 to positive infinity. What else could I do? Well, other things I could do are I could pick somewhere else. So remember, our picture kind of looked like this. We had an important spot at square root of 5. That's where we had to make this transition from 1 to this other solution. Okay, see that? In order to meet the IVP. Right? Because if I plug in 3 to here, sorry, my initial value was y of 3 is -7, right? If I plug 3 in here, I'm definitely not getting -7 out. I'm getting 1 out. So to make it meet the IVP, I have to use this stuff. And there was a plus or minus on that. To make it get down to y of 3 is -7, you have to use the minus branch. Okay? So that's why I have that transition at square root of 5. And then where's the other spot I can smoothly get off of 1? Yeah, the only other spot you can smoothly get on and off is at -√5. You guys see that?
So then that's the largest interval, I guess. That's what it means is.
So I can make this kind of funky, like, all right, if I want to just go with these functions, 1 and x squared minus 5 quantity to the 3/2 with a plus or minus on the front, plus 1. Like if those are the functions I'm willing to deal with, then this thing has only the solutions that are either 1 in this piece, or plus or minus the thing. I'm going to call this from now on the thing. Okay? So in here you can be either 1 or plus or minus the thing. In here you can be either 1 or plus or minus the thing. And in here you can be either 1 or plus or minus the thing. I lied to you just now.
You can't be plus or minus the thing between the two.
You can't be plus or minus the thing in here, that's not allowed. You guys see that? So in this space, you're only allowed to be 1. Now, where did the 5 come from?
Calibration and like.
Yeah, the 5 came from me calibrating my model to match an initial value condition, right? So that was out here at 3. To get to 3, I had to make my, right? I had to make this minus the thing. You guys all with that? That choice was given by that initial value condition. Now the interesting thing is, once I made that choice for the initial value condition over here, I don't really need that over here, because the 5 was from that initial value condition. It wasn't from solving this in general, it was solving it with that initial value. So if I'm willing to change where I transition, it changes what solution you transition onto. You guys see that? So if you were willing to take one of your parts of your y as plus or minus x squared minus c to the 3/2 plus 1, then the question becomes, where could you get onto that?
Left of square root of 5?
So it has to be left of square root of 5, and also it has to be the spot where the derivative of that thing zeroes out.
Yeah.
So it has to be the analog of square root of 5. You guys see that?
So for whatever C, it's like.
So for whatever c, it dictates where you can get on and off.
Why do we need to transition smoothly though?
Because otherwise it doesn't solve a differential equation, because you can't take the derivative.
Yeah.
And so if you want this to satisfy, if you want the differential equation to be satisfied everywhere and meet that initial value condition, over here past root 5, you have to be negative the thing. For at least a little while in between root 5 and somewhere, you have to be 1. And then you can pick where you get off, but that dictates which solution you go on.
So this IVP forced us to choose what we have to the right of root 5.
Yep.
But since we have some weird,
Yeah, since this one's particularly weird.
there's still infinitely many curves to the left of that kind of, that we can slide around and pick from.
Yeah, so if you're thinking about this in terms of existence and uniqueness, right? There exists a unique solution around 3 until you get to until you get to somewhat less than root 5. In which case you could have stepped off of 1 onto something else. It turns out that if you think about it a little bit, you can't actually step off till after 0. Because each of these is going to have a transition point that's a plus point and a minus point, and the plus one's going to transition off to minus the thing, give or take. So you'll have to go past 0 to transition. But yeah, you've got a kind of a case where you've got like 1, and then some function that looks like this, and then over here, depending on where you step off, you might get onto something that looks like this, or you might get onto something that looks like that, or something that looks like this. Where you could go further down here and step off and get on something else. So that's kind of why the back of the book has this kind of funky thing where they limit this for x is smaller than negative the square root of c. Does that help?
Yeah.
That was mega confusing. Good work for sorting any of that.